Hello, everybody. I think we're live. So it seems. Welcome to another day where we build a 3D game engine in Golang. And really, this time we're doing Flappy Bird, day number 2 for Flappy Bird, just to test our engine, see what's missing, potentially move some things from Flappy Bird back into the engine when we're done, so on. Now, I know it's been quite a while since last time. It's been like 4 weeks, but life happens. So we'll pick right off. Well, let's see. So here I have Flappy Bird open. Let's just run, like to always run, see where we are. So this is where we reached last time. Got these graphics showing on screen. They move and we can jump by pressing the space bar, but it's very ugly. And we have this, wherever there is transparency, we have kind of the white pixels everywhere there where transparency is supposed to be. The ordering is correct, so the bird does come on top of the pipes, but then we only have a few of them, and we don't, like, they look stretched, so we don't have proper graphics as well. So let's fix these one by one. They move on because it's too ugly. It's really ugly. Let's see. So first, I'm going to go to the branch we have now I made, and this doesn't run yet. We'll see why. Yeah. Okay. So I did very simple things since last time. One is I just updated to a new version of nMage, which we'll discuss what the differences were, and I updated to Go 1.18, which gives us generics finally. Might be useful for this project. We'll see. Now, what's the difference here? Well, one of the things that happen is wherever there is transparency, essentially OpenGL doesn't know how to deal with the alpha values, and so all we get is white. And to fix this, we need to blend. So we need to tell OpenGL if there is a pixel already, so maybe the background is black, and we have some alpha, don't just draw the alpha. Don't just show white or overwrite the background pixels. What we want to happen is, if our object is transparent, even partially, we want to combine it with the pixels behind it. And that's all that transparency is. If it's completely transparent, like the edges around the bird, then we don't want anything to show. And that's very easy to enable, and you can actually see it. We go to Advanced OpenGL, Blending. It has nice descriptions of what's happening, but this is essentially what we're getting. And by what we want is this. And the way we're going to do it is by doing these two lines. We're going to enable blending, and then we're going to say how the blending is going to happen. Where we have, okay, for the source pixel, we have the alpha, and then for the destination pixel, we have 1 minus the alpha. And the full alpha means the object is opaque, so it's not transparent, and 0 means it's fully transparent. And we can see, some of the equations here, what they mean, and how they overlay, how the equation is done as well. So the background is called the destination, where we want to draw on. And so the destination here is red with 1 alpha. And here the green is green, which is the source, with partial transparency, so 0.6 alpha, 60%. And then you multiply this. So you multiply this with the color, and then this one with 1 minus. So 0.6 is the alpha, that's the source alpha, and then 1 minus the alpha here. And what you get is a mix between the two colors. In this case, the update to nMage was just basically enabling this. So if we go to nMage in the engine, now all we do is along with enabling a bunch of things, now we just enable blending and we put the this function, which is I think the most standard blending function that you find around. It gives you natural results essentially. Now another thing is I got some new resources for our textures. So these look much nicer than the old. So we have all the numbers, we have proper backgrounds, and we even have potentially an animating bird, right? Because we have three different sprites and a more proper what do you call this, a pipe, right? And a background and the ground. So that's much nicer. So we just need to edit the names. That's why it's actually crashing right now. So blending is already enabled, so we don't have any more issues with transparency. Hopefully, let's now fix the naming. So you can come, instead of bird.png, we'll have the mid flap. And then for the pipe, what is it called here? Pipe green. So we'll do pipe green. Let's run. Much nicer already. We got rid of stretching. Although that doesn't seem like proper blending, is it? That's very weird. That's maybe with the ordering. So it's like blending with the background, which is black, and that's why it's coming out as black. Let's see. So one thing we have now is everything is on 0. So the pipes are positioned as Z0, so they're 0 depth from the camera. So you have X, Y, and then Z goes backwards. But the bird is also at 0. So where's the bird? Bird translation matrix is this, which is 0, 0, 0. It's the identity matrix, and then we have a 0 translation. So let's move the bird by like 2. See if this helps. So essentially, we put it to make sure it's in front. That didn't help. Okay, so that's one thing to look at, which is why the bird is, I guess. But yeah, we got rid of stretching at least. So this seems nice. Let's see. Let's look at the image. Is it transparent? Does look like it. Let's do paint.net. Let's get this guy. Yep, it's transparent. That is weird. We are on the latest. Yes, we are. We can check. Where is the net? Right here. Do you have the correct version? Yes, we do. 1 minus source alpha. Cool. That's one thing. Fragment shader is fine. Well, we'll come back to it. Let's add some more things. So I want a background, and this honestly we need to get rid of. That we have to do like an FBX and these things to have a quad, essentially. Like just all we need is a square, 2 triangles, and we can have a sprite, a 2D image essentially on the engine. We focus on 3D, so we don't have kind of an easy way of doing this. So maybe that's one thing we want to do, is do a quad system. Yes, to do support quads. I say sprites through quads, right? Okay, for now, I'm going to take this. Instead of this being the pipe, this is, what what do you call it? Background mesh. We have a name, background. Ensure the model doesn't matter, it's just a box. And then we load the background texture. The background texture is background-day. Go, and we need to put them. Background mesh, background texture. Cool. Now we need to display them in render. We honestly want different materials, but sure, we'll just reuse one. We should bind here just to be safe. So the bird, the pipes, we should draw before all of these. Draw background. So background comes first, and then else. Background. Cute. Background mesh. Going to position and material we have. The mesh doesn't need to be reset every time, honestly. But yeah, let's do one thing at a time. Okay, so we need a position. So you can do it here. Background translation mat is just default. I don't think we need to move it, but we probably do need to scale it differently. But let's see. That's it. Let's check. Okay, it's tiny. Is it cropped? What is happening here? Yeah, it's cropped. Interesting. Why would it be cropped? Are the meshes different? Because if the UVs don't stretch over the whole thing, but I think they do. Well, let's try like bird.px. Mesh. Okay. Okay, let's scale it. So on start, we can say background translation mat scale and new vec3. Let's scale by like 10. Oof. One of the reasons we need a quad class, because this is not being applied correctly at all. This is not even completely wrong. Background day. Mesh. Should we make a quad class now? Maybe we should. You know what? Let's do it. it's a 2D game. We should at least do proper 2D graphics. So quads, and let's do quads.go. And after this, honestly, we need a new movement system, like an object system, because this is garbage. We are putting like translation matrices and like speeds and positions all over the place. This is not clean. So let's have to do add a proper game, like game objects / entity class struct. Right. So what's quad? Let's think about this. Let's get a new too zoomed in, too small. Yeah. We have a texture, which is a 2D image, and we want to put it on a model. So we need a bunch of vertices, and we need to put the texture on them. So if this is a vertex, sorry, I'm doing this with the mouse, but let's say we have these vertices, and we join them. Obviously, we need to triangulate. So we have this triangle and this triangle. So we're not making a cube like we're doing now. Right now we're doing a cube, and we are showing one face of it because we're doing an orthographic camera, so the sides don't show. It's exactly facing the camera, so we don't see the sides, top or bottom. But really, that's a waste. We're wasting performance because all we really need and see is 4 vertices, the front. We don't care about any. It's a 2D game. And then I don't remember the UV coordinates. I think they start here. We can check. And then this is 1, 1. And these are the UVs. That's it. Then you take the texture and just stretch it on the whole quad. That's it. There's nothing else. It's basically the same no matter the sprite. Here, like you'll have a bird or whatever. You'll have our background, right, that we have now with the clouds and so on. It's just stretched over the quad. Let's see OpenGL UV. Yep. So 0, 0 is bottom left, 1, 1 is there. And what we're doing in Blender when we are exporting this, we are essentially just we're making a cube like this, and we're setting the UVs. But we don't need that. We don't need a cube. We can use the same set of vertices for different sprites. Every time, the only thing we're changing is texture. So think of what's the simplest way of doing this. Let's see. So it's essentially like when you ask us to load a sprite, you say, well, here is the PNG, here's the texture I want to load, and see if okay. And we internally get a mesh of exactly these 4 vertices and being set up with the proper UV coordinates, and then putting this image on top, this texture on top, and we're done, right? Without you having to specify your own model. That's all there is. So we need to replicate what a mesh is doing and have a texture along with it, right? That's really it. But the mesh won't be loaded externally, right? It's just going to be internal. But we'll do more or less all of this, right? Yeah. So let's have quad, right? And a quad has in it, I'm not sure if we'll need it, but we'll keep it. Meshes.mesh. And oops, where do you go? Texture, which is this is the texture, and that's about it. And then we have func new quad, and you give us your own texture or really sprite path, I guess. That's necessary. We give you back a quad. There you go. Now, okay, let's create one. So I don't want to fight. We can honestly we can create them directly. Let's look at this. You just code them. What's a mesh? A mesh is just a name and a buffer. And a buffer has these, so we can create these, and then you need an index buffer and stride layout. So we can code a buffer. It's just 4 vertices. It's not a lot. So we have a mesh, and then we create a new buffer to it. Layout. And optional colors, which we probably won't use. And then vertices and normals. Normals here are easy, but this is the important part, right? Texture coordinates. Then we interleave them. Yeah, it's just a bunch of code. Probably better to load it for now. Okay, so I'll do something very lazy. Instead of writing a bunch of code, we will make a, and I really need to learn Blender a bit better. Okay, add a mesh, a plane. There you go. And yes, that's it. That's all we need. We don't need a cube. 4 vertices. That's it. It's not triangulated, which is I don't know how to tell it. Please triangulate. But we can do it in post-processing when we load it with the ASMP. ASMP will do this for us. But I wonder, can we do it? Modifier. Triangle. Oh, there we go. Okay. So how do you apply this? Do we? Anyway, so let's do this. Then let's add a texture just to test. So we go here, if I remember correctly, so we do it every time I get confused. There you go. Now we need let's see exactly material. Yeah, there we go. The base color is image texture, and image texture, let's go to desktop, dev, nMage, and where is Flappy textures, and let's do image flap. There we go. We can see the transparency dying here as well, but this is what we need. So this is a correct application here. It's good. Where is this thing? texture paint. All this matter. Just wanted to check. Okay, let's cancel it. Cancel. I don't want to export any materials. So this is enough. Really, I guess you can just export this. So let's go and say export to. In this case, let's just do obj so we can look at it. Textures, models. Quad.obj. That's it. Include normals, yes. Write materials, no. Triangulate, yes. Exports. Cool. Okay. Now let's look at these. Quad.obj. Plane. I think that's it. Two faces. One. And I don't remember how to read this, but 1, 2, 3, 4 vertices, 4 normals. Is this tangent? BN. Normal, that's a normal, and then 2 faces. Okay. Okay, let's load and see. So the background, let's load quad.obj, this guy, and reset scale. Oh, the background went. Completely disappeared. Why though? Okay, it's here. As we expect. Render background. Texture and the buffer. To get it. Okay, let's just change the color. Clear color. Yeah. Let's make it red. So this is the default color of the background. Yeah, so the transparency, the blend is not being applied for some reason. Is it being overridden somewhere, maybe? And the background is nowhere to be seen. Let's start with the blend. Let's force it. gl.enable blend, and blend function, the source is source alpha. The other guy is 1 minus source alpha. Version is correct. Now stir it. A sword. Makes no sense. The bird is in front of the pipes. So why is he? Oh, we're drawing the bird first. All right. So the bird is being drawn to the screen. And then, so the pixels of the bird are being applied, and so what exists behind the bird? The transparency sees the red color, and then we draw the pipes. So I am pretty sure if we move this, now if there are pipes, the pixels will see the pipes, not red. There we go. Nice. Okay, cool. Very, very nice. So blending is applied, it's just that our order was wrong. Cool. Beautiful. So we have this. I don't think we need these anymore. Yeah, we don't. It's already in the engine. Okay, the red is too much. Color. Okay, so back to our quad. So you got the quad, you got this. Very weird. Okay, let's set, because I want to see all the buffers before anything happens. Let's do this. Background. Might want to try drawing just the background and seeing this makes a difference for now. Yeah. Oh, the debugger is always so slow. Come on. So essentially what I want while this loads is just this. We'll do this. We should return an error as well, potentially. And quad mesh. Finally. Wait, what? It's loading nMage. The wrong thing. You're loading the wrong thing. Very wrong thing. Workspace folder. Tags debug. Yes. But I want to turn this, please. How does it choose nMage? Just says workspace folder. Oh, add config. Oh, there we go. Flappy nMage. Go. I think, I guess. Let's see. Maybe. Desktop dev debug bin. We're in the wrong place. Okay. Where's this? Okay, finally. Let me nMage. So why was this running the nMage thing? The hell? Crazy. Undefined pipe, new pipe. Do you mean undefined terms? What? Seems like it's working now. Finally, great. Auto never works. Okay. Way too many vertices, first of all. Or no, this is what's its name? Bird. Okay, this is the bird. That's because we have a cube. This is the pipe. This is the background. Okay. 5, 6. Okay, so it's not joining, it's not optimizing the mesh. That's fine. So we have 3 vertices and then 2 triangles. Well, where the vertices are not being merged. Okay, sure. And 6 normals and texture coordinates, they look fine. So only on the edges. 0, 1, no, actually they're not fine. 0. Let's see. Let's see. Ugh. There you go. Transparency hits. So our UVs 0, 0, 0, 1, 1, 0, 1. That's what we should get. 0, 0, 0, 1, 1, 0, 1, 1. Okay. So we get those. And we have no colors, we interleave, and then the faces 0, 1, 2, 3, 4, 5. Yeah, cool, looks good. I'd like to optimize, so asig dot post process and optimize meshes. Bird, pipe, background. Now we should have 4 vertices. We still have these. What? Didn't optimize. There's not optimization. Didn't optimize. Okay, back to Blender. Is there anything we can do? Let's say, and I assume it's Blender. I'm not sure because this looks fine. So why are we not getting the thing? This looks okay. If the UVs were wrong, this image would be distorted. Here we have the X and the Y axis. Yep, this is how it would look. Is the rotation bad? Actually, the rotation might be, we might be looking at it from the side like this. Okay. So let's rotate and see, because the camera is looking at minus z-axis. Actually, its position is at -10 and it's looking along the positive z-axis into 0. And this we can see with camera target. Yeah, there we go. Actually, we're right at it. So we are positioned here at -10 on the z, and we are looking at 0. Now, this guy is coming for us like this, right? Because when we export it, and I wonder if this can fix here. Forward, where is forward, where is up? Yeah, I think for it up means so where the normal is looking. So the normal is like this. This is this up, so it's lying like this. Okay, let's rotate. Here, let's take this guy and set the matrix to be not scale. Let's rotate this guy. Rotate 90 degrees into actually degrees to radians, and then the axis of rotation is, I think, the x-axis. New x3, so 1 on the x, I think, and we can get test. Oh, correct. There we go. Beautiful. And I think we have the full image, sky, clouds, and then some grass. Yep, that's too small. Cool. So now we know a bunch of things to do. When we have this, remove this breakpoint. When we have a quad, is we can load now this quad, which is not efficient, because why would you load it every time? But it's okay. We can load it once and then just initiate a new mesh every time with the same stuff. That will probably be better, since we're lazy about writing the code ourselves. Yeah. So we'll do, maybe we'll give a sprite name. We'll use it here, sprite name. We're loading this quad, and there is nothing to be done with it. Quad mesh. Error. Same thing. Okay. And then the texture is sprite path. So this is just the sprite. Then our mesh is the mesh, and the texture is sprites. Texture. And where is that? Oh, right. No, ours. Cool. Now, the question is this quad only graphically, or is it a full, what I would call like a game object? And I would say it's a type of game object, because what's the point of this if then you are going to need to rotate it and so on? So it makes sense to also give back a quad with a position, to have a scale and so on, but for it to be rotated already 90 degrees in this case, since we know our quads need to face the camera, at least for this camera. We need their forward to be, the forward should be the z-axis, I think, instead of y. Yeah, so I think this is on the exports, not on anything else. All right. Let's see if, so our forward, at least for this type of camera, we assume this is the default orthographic, our forward would be Z forward, I think. 1 second. So about this. Okay. Honestly, I don't want to rely on this. Let's try it. Let's see. I would like to see it. OBJ and set forward. Okay. And then it's not rotate. Let's see. Nope. Is there any difference? Doesn't seem so. And then the same rotation will give us the correct. Okay, it's just flipped now. So it's looking the other way. So it did have an effect. OJ. So essentially we want this. So forward would be the y-axis if we want it to work in our dimensions. And up is z. It's okay, yeah, let's do this. Forward is y. Cool. So this now needs some rotation. This is like the difference between Unity. I think Unreal, I'm not sure Unreal does this, but some 3D programs and game engines have different things that they consider up. So in some of them, this up and the forward. So for some of them, the up direction, and then you have kind of forward one like this. In Unity and Blender, I think Blender as well, they're like this. Z is forward, up is Y. I think for us right now, what's happening is like this. Not really, but at least to align with the camera. This is what's happening. This is what's required for us to load it without any rotation, is to have it like this. Yeah. So the quad wants to have essentially wants to have this. No. So it was doing this before. Yeah, so its forward was going with the Z, this side with Y. Yeah, so the forward is where the face is pointing towards. So here the face is pointing towards us, and we're looking on the Z axis, right? Yeah, but when we bring it into our end, we're looking different size. That's fine. Let's see. So now we have an image that we can just load without changing rotations or anything. And right here, our quad system is just going to hard code a model and then a PNG. PNG is chosen by the user, but this thing is hard coded. But we need positions. Now we don't have a proper system for dealing with positions, rotations, and so on. And the translation matrix, honestly, is just horrible. I really don't like it. I think I'm going to remove this from GGLM or just heavily change it. Fortunately, we do rely on it, but I think it's going to heavily change, because in this matrix, the scale and rotation are combined, and it's not clear how to do it. Like, let's see. So you have translation matrix, and you can scale it, and then you can rotate it as well. But now the numbers for scale rotation are combined. It's not clear what the scale is and what the rotation is. You have to do some math to undo them. It's not always accurate and so on. So what we usually do, I think in a lot of places, like the technique is, you don't do that. Yes, to the draw functions, or in some places where it's needed, you do use the matrix, but you don't work with the matrix. The matrix contains scale, rotation, and position, right? Translation. Three things. But these things we store independently. We have a scale vector, we have a translation, a rotation. And then when we need, we use these to produce a matrix out of these three numbers. So what I would like to do is, for now, I'll go to an entity package. The entity is very simple, and the nMage will probably have a lot more involved entity system. But for now, what's an entity? I'm just going to do. We don't need an ID in this one, but it one will have. For now, I'll just do. We need a position, which is vector 3. We need a scale, which is similarly a vector 3, and the rotation, which is a quaternion. That's it. Now, you do have a translation matrix, which is, I think, basically the model matrix, right? Yeah. Where is this? Draw, nMage, render. Yeah, it's the model matrix. So the model matrix is produced out of these. And when we change one of these, we essentially have to recalculate the translation matrix. The issue is, when do you recalculate? So usually there is an additional thing, it's like is dirty, the boolean. And if you touch one of these, then when we come to draw, we have to recalculate the matrix using these values and then draw. Otherwise, if it's like a static object, these things don't change ever. After the game starts, it never changes. So why are you recalculating for all your geometry? So instead, we just immediately use the translation matrix. But that obviously means that you have to have controlled access to positions, to like position scale rotation. So like when you want to touch the position, you have to call a function so that function remembers to set the isDirty flag. Because if you change the position, forget to set isDirty to true, you're going to forget to you'll not calculate the translation matrix, and the object will not appear in the right place, or the right scale rotation, whatever it is. So you might even maybe make these private and just have functions that do them. I'm not sure. In something like C#, you would have properties, if you have seen them. So if you look at Unity, all of them are properties. So when you change the vector 3, a function is running. It's not actually changing it directly, but makes it easy to kind of deal with. So in here, what we might do is we keep them private and we give some nice functions. So func e entity, and this is by no means like what we'll use in nMage, but it's a good start because we never done this before. We're getting more into the gameplay stuff than the very fundamentals that we used to do before, like with rendering and whatnot, and the engine structure. So we don't want to re-implement all the functions that exist on position, scale, and so on. So I think read something like position mutable, which returns a vec3. So these are pointers. So you can just return the pointer and they change it. We change it here. But since we're saying, hey, we're giving you something that when you change will change on our end, we can do e.isDirty equals true. I think this is a nice way. We don't really handle logic. We just say, are you reading it read only or are you changing it? But if you don't want to change it, just read only. We can do immutable. I hope the spelling is right. In this case, we don't return a pointer. We do a copy like this to make it very clear, like, hey, we're giving this to you. If you change it, in this case, we don't need set isDirty true. Same thing here. So scale mutable scale, and I don't like mutable. So read only. We just say read and read write. Read write. I think it's clearer. Read write. Great. Here we just do, here's your scale. And rotation read writes, which is a quaternion. And it's just a vec4. Yeah, that's it. So this way we have controlled access. We know we will assume that if you requested read write, then you'll probably have changed it, and in that case, we set isDirty. I will keep isDirty public in case you maybe, I don't know, you read this in the like where you have an optional case where sometimes you will actually change it, sometimes not. So if not, you can set it to false. But yeah, this guy we probably want to control access to as well. We shall call model mat to be clear, and then we'll essentially have to check. So we say model mat, right? And we'll give you a TR matrix. It will hopefully not change, but yeah, otherwise it's too slow. The only difference, the reason this is a function is because here we'll check if EE is dirty. If we're not dirty, this thing is up to date. We can return it immediately. But if it is, and I don't think GGLM has functions for this, but we essentially new, yeah, it just has functions for position data. That's it. Yep. Yeah, multiply. might make sense. Like we'll use this and then we scale and then rotate. I think, is that the correct way? Let's see, let's read on it. So model matrix from I think we did this somewhere. Where was this? Scale, translate, rotate. Yeah, it's like that guy's talking about. That's why, you know, this is better all abstracted away, because otherwise it gets really confusing. You have to get your thing, scale, rotate, translate, otherwise you fall into, sorry, I didn't zoom in, you fall into these traps. If you move it and then scale it, then it's relative to the origin, so you get a huge change. So you better scale, move it, and then you can rotate freely. My understanding. So we want something like this. So let's get translation matrix identity. Right, so E module mat equals this. Scaled by E.scale. And then translates by E.position. And then rotates. Unfortunately, it's radians and axis. So we'll do E dot rotation dot. I think GGLM has stuff for this. Axis. Gets the axis. And we have we should specify whether this is radians or not, but it probably is. And we should have one single function that does this, honestly. But yeah, okay. GLM, let's just see. Angle quaternion. Oh. Axis. No, that's just from. Okay, so since they are independent anyway, we want an angle. Here's your angle, and you want an axis, and here's your axis. Very simple. That's it. So in this case, we can remove is dirty, then get this, and that's it. That's really it. Yeah, and then you can do new entity, trans entity, position is new x3. Is there no default x3? Yeah, it's okay. It's better. Oh. Scale, same thing. Actually, scale is 1-on-1. Start. Rotation is quad identity. And then model matrix is new tr mat id. This dirty is already false. I think, yeah. Everything's fine. Cool. This way, now we can embed an entity. Entity dot entity inside. So we kind of inherit all of these. When we create it, we can set the entity to entity.new entity. That's that. We don't need to return a pointer. It's all pointers anyway. That's it. This looks good. Looks nice. So now, let's start with the background since this is the most recent addition. So we have this. Let's copy this guy. Remove all this. Now, quads dot new quad. Sprite name, sprite path, this guy, and background sprites, and there. And here, I'll do yeah. Fail to load sprite. No. Ooh, so material is interesting because you potentially need a material in the simple, like the naive implementation without any kind of batching. We need a mesh potentially per sprite and the material per sprite, which is a ton. If you imagine a game, you have a lot of sprites on screen, and so many times you'll actually use a more optimized way. But for now, we'll keep up with this. I'll even keep this material. Let's not complicate it further, and we'll just do, well, here's my sprite, here's my texture.id, and here's my thing with a mesh, and yeah, it's all parts of the thing. Now this guy we don't want anymore. Goodbye. we'll instead do .model map. That's it. Simpler, very nice. Now, there's one of the places where the API becomes much nicer, much easier to use, is now I can just do the pipes. Here I can do background. So background sprites dot dot entity dot scale, and we want it for read write because we're going to change it. Then we can do set. Let's set it to, so x, let's do a 10 on both, keep it 1 on the z. Nice. Now it's looking like a real game, and this is all in an engine that we did. How cool is that? You guys tell me. How cool is that? Very cool. All right. And 1010 filled it exactly because our camera is an orthographic camera with, I think, 1010 as well. Somewhere I saw it. There we go. The bounds are 10. We can test it. It's really cool, I think. It's looking like a proper game. Yeah. Smaller, so around 10% has been cropped. But yeah. We can see some dark edges, and I think these are pixels on the sprite itself that we can change. Already, this thing looks clean, so I'm not sure why we're getting. Anyway, this is a small thing. So we have this new API, nicer API for doing sprites instead of all these different things. So let's do it. Let's change the rest to this thing. So here I'll do quads. The new quad. We might be better to say sprite. It's a bit more than just a quad. A quad is just the shape. It's the mesh. We'll see. We'll see. So we'll do bird quad. No need for a mesh. Why is that? Oh yeah, of course. So this guy is now also closed quad. No need for a separate mesh. No need for a separate identity matrix. Sorry, a model matrix. Now all of these are much cleaner now. Bird quad dot entity dot. You don't need to do dot entity. You can just do, I think, dot scale, since it's embedded, like we'll find it. Yeah. Scale read write dot, and we can do it in any order. That's the beauty here. Not like before where we must do it in this order because of the translation matrix. Here they're independent vectors, and only at the very end do they get recalculated, and they get recalculated in the correct order. So we can change the order in this case. Now we want to scale it, and then we'll set to this guy. Do we have another set function? No, that's fine. So we'll do yes, cool. I'll even, let's do this. Let's translate beforehand. So we'll do position read write. There we go. Oh, right. Let's set at this. And then we can rotate. We call it bird quad rotation read writes dot set. It's really this. angle axis, add this is a weird thing, weird API. Should improve it. So many things to improve. Right, so we don't have a way of updating this guy nicely without making a new thing. So we have this rotation. I'm not sure if I can set it. New quaternion angle axis, and this is what we want. But we can't write this. Yeah. Anyway, so let's get rotation, bird rot, and we'll do bird rotation. Where is that? Get back not used. You are actually used. Vector 3 and plot. Okay. Cool. Can I do it directly? Okay, cool. So we're essentially getting a pointer to the thing, and then if for anyone who's not familiar with this, we dereference it here and then set it to the value. We're essentially changing the value of the original pointer. So the rotation will change on the thing. I don't think this rotation is actually necessary anymore since we have the quad with proper rotation already, but we'll see. Now here we have some translation happening with this position, but this is now much nicer than before. All we have to do is a position read write and then set this guy dot x, this guy dot y, this guy dot z, and this also needs a proper API, honestly. Yeah, that's it. And this is always, setting the as dirty flag and so on. And here, extra ID, even draw, like you can imagine now, if you want to have full or like natural 2D systems in the engine, instead of a draw like this, and then we have to like do dot dot and so on, we can just have a draw sprite. You're done. So this is for later. It's still nice that we can do all of these. Word quad dot mesh, model mat, and this. Okay. It's probably rotated wrong. Yeah, it's not even there. Not even there. Let's go back to rotation. This guy, can move it. Don't need rotation anymore. Nope, still not there. Oh, by the way, where's this 9? Make it 10. To have full background. Yep. So nice. But position. This shouldn't make a difference. Yeah, this. I'm not sure. Where did we go? Mr. Bird. Bird, bird, bird. Bird. Okay. Bird velocity stuff. And then we set, oh, it's a delta, I think. Right. What was the old thing? Oh, it's already, yeah, it's a translation. It's a delta, not an absolute value. It's not a set. It should be a translation. So where is this guy? There. So we're setting it, but this is a delta. And this is one of the good parts about having your names properly. So we want to do, and again, oh, we have an add, thank God. We just want delta. Here, take this, please. And yes, here's the point. That's it. Cool. And yes, we did not need the rotation. I really hate the edges. There's something at the nose. The guy. What? He's looking like a game? Okay. The pipes, I hope, are not too painful. So what's the pipe? So we did this. You can see. Oh, we had this? Really? We did this thing called a transform, but it doesn't seem we used it. Interesting. Yeah, we don't need this anymore. I completely forgot about that. So yeah, so the pipes now, how long have we been going? Okay. The pipes. So the idea is once they go off screen, I guess. So our pipes, some of them at least, you know, say this is the pipe going like this. It enters the screen, so they start off screen outside the camera view, and then they go here. And what we want to do is when they reach outside, we want to reset them back and then adjust the height vertically, so next time they're like this, right? And so on. And then third time they're like this. That's how the game continues forever, but with only a few actual meshes and so on. So let's see. I don't want us to put one over the other. So like if we have too many pipes coming in, so let's say we have them like, so we started one here, one was here already at the start of the game, one was here, one was here, one was here. When we move this, we don't want it to come on top of this guy like this, for example, because then when they move, they're going to appear on top of each other. So we need to put it after the last one, wherever the last one is. We want to put it behind it. Yeah. And we don't want it to be too far off. Like we can say, well, you know, we'll just put it so far, then the distance between them will not be consistent. The distance between them needs to be consistent. One thing, and I don't think that's the most efficient, but whatever. We can look at which one. So let's say, I don't know, this is the x-axis. So which one has the biggest x-axis position? Well, we just need to be to the right of that one, a small amount, and that's it. So I think that's the simplest solution. Let's go with it. So in our update, here we move the pipes, and then I don't think we need the original position. We don't even use it. Yeah, for this solution to work, we just need to make sure that we always have a pipe on the edge. Like the screen should never be empty, and that's already part of the game. So we can remove this guy. No need for you. Translation. Matrix. Yeah, so we're doing all the work here. And position is essentially for logic, and this is one of the reasons you want an entity like the quad. So instead of all of this, let's say that the pipe is nothing more than an entity with a bunch of more things, like should regen or whatever it is. Even should regen we really don't need. So we just pick. Well, let's say quads. Dot quad. We just embed one. Or no. And pipes are always using this guy, right green. So you can say, well, your quad is quads.new quad. It's a pipe, and it's does this. Q, and if not Q, then panic. Failed to create quad pipe. Pipe quad. Error. Pipe. Not this. If error is not null, then like that. Then we can just say this guy. Right. Okay. Now this should make no difference. Just to check. Okay. Now I want to remove the reliance on these two guys since they are embedded as part of the quad. No need for this. No need for this. All these boys now. Yeah, this is the old API where we had to repeat stuff. Although, why does the translation in the position different? I have no idea. 12. Okay, so we have some spacing. Position. add 10. Okay, let's copy it for now. So we have, let's get a position read writes. And we want to well, I'll just copy this for now to be exact, and then we can improve it if possible. I just don't understand the 10 and the 14. Why? They should be both representing the same thing. So, well, we'll do this now. And they are all starting at 0, I think. Yeah. We have 0, so this add doesn't, I think, doesn't make a difference. You can do a set instead. Give these for now, and then we scale by this guy, which is fine. P dot scale read write dot set 0, 10, 0. Oops. And here we do same thing, but minus 10 on the Y, and same scale. Oh, we're not using Q now, are we? Yeah, we need the rotation. So we can do this. And now I can do rotate, read writes equals this guy, just like we did before. So we are setting the rotation from the start like this. That should be, we don't need much simpler, much nicer. Okay. So we don't need all of these. You can just add directly, I assume. So this comment again, and then position read write add. No point in having this up. We shouldn't regen, move it, and then next position was read. So this is one use for the read. Might make sense to copy it to give all the functions. Yeah, because then you don't get access to all the functions. So what we want to do is whenever we read, the idea is we just want to return a copy, not a pointer to the original one. So I think we have a clone. Yes, we do. I can just use this clone. Scale read is the same, and rotation read is the same. So clone and where is that? Oh, the clone is on the vec4, not on the thing, not on the quaternion itself. So that's fine. What we can do is have a var q be this guy, and return q. What's wrong? What is wrong? What? Oh yeah. So we're copying it by having this dereference, and then we take a pointer again, and that's that. So now, instead of this, I get this. Okay. This guy. Here we need a read write. We use it multiple times, so might make sense. What's this PyProject anyway? I'm not sure if this is a bug or not, but it's being set to the y of the one. I plus 1 is being set to this guy, to the one before it. Maybe this makes sense. And this we don't need anymore. This translation is done for us. Nice. So if we should regen, basically we should move back. So first we move them, and then if they are less than 10, greater than 12, okay. Let's copy exactly for now. See. Cool. Oh, we have nothing now. Could be the rotation, just like what happened before. So where are we rotating? On the y-axis, but on the z as well. Let's see. Nope. Could be something else. like the movement, for example, but the movements should be the same. We didn't do much. Here, we're adding pipe logic is kept the same. This I didn't touch, so this is just a read. This is okay. Should regen. So here we are regenerating essentially, I think. And then to draw them, oh, pipe text. Oh, these we don't use anymore. And these we don't do anymore. Use this guy. Buffer from each. And oh, where did the bird go? Or bird completely went. It's the bird. It's potentially behind the pipes, by the way. Background and then pipes and then birdie. It's the birdie. Okay. We're always using, this looks like another mistake. I mean, I just did this mistake. Yeah, it was always the mesh before one mesh and one texture, which makes sense, but not the matrix. Yeah, let's just do I. No, 0 makes sense, actually. Yeah, the different model matrices. Okay, so the position, we started at 12, so just be on the screen, I think. And then we set, we add 0, we add this. We add I don't get why we have an add there. Shouldn't matter. But let's try it. Because we do start at 0 in the beginning. we get a new pipe with a position of 0, and then we add to it position x. Why don't you just set the position x? Don't know. No pipes yet. Okay. Let's just copy, make sure everything is the same. Add here. Then we scale 0, 0, 10. I think the scale should be 1 here. Yeah. Because here we are setting scale. Okay, this is probably it. Actually, we're setting the x-axis x scale to 0, so obviously we'll not see anything. That's definitely one reason. Seems like there are others. Come on, guys, move. Okay, so scale looks okay, I guess. Let's look at the update. Position add. Cool. Let's look at the difference. Okay, so we get the position of a pipe. Then these lines were deleted. So our position set y to position y with random offsets on this and the next pipe. Now this probably should be a +1 as well, but I'm not sure. You can try. Either way, still should show us some pipes at least. So we have, well, who sets region? This code doesn't work right now at all because should region is always false. So I guess we can't forget this for now and come back to it later. What about drawing? Drawing should be fine. A new pipe does this guy. And oh, we never tried changing the pipes to the new system. Oh, we should try that. Okay, luckily the new system is now easy to do. So let's try just to have a pipe, test pipe, and you can steal this. Okay, and okay. Let's draw it. After everything. tests. So this is all defaults. Let's see now if we get a simple pipe somewhere. No, we don't. Seems not. Okay, so now we can start playing with it, because we know kind of it's not being applied to the quad as we might expect. Yeah. Okay, first of all, let's do a position. No. Scale read write and set just to make sure. Scale to all ones. And do position read write and set 0, 0, 0. Let's just do a 2 on the C. No. Do a -2. Oh, I'm doing a read. It's one of the dangers of this API. Read write. Read write. No. When do I disappear? I think a while ago I completely disappeared. Okay. But, okay, let's draw only this, nothing else. Oh, there it is. Interesting. So was it drawn behind things? What was happening here, people? And if we don't set anything, does it disappear? Is this... No, it's there. And I think this essentially was something like 10. There you go. Okay. I'm so confused. The other pipes are still not being drawn, but we know at the very least that this one does work properly. Pipes, new quad. New quad, and oh, we are playing with the rotation actually. This could be it. Definitely. There we go. Yeah, it's the rotation. Completely forgot about that. And the offsets are kind of wrong. I think I know when the offsets are wrong. Maybe this, because I added a +1 here. That's worse. Definitely worse. So it was the rotation, and I think we wanted to rotate so that essentially if the pipe by default is pointing down or is pointing up or not, the image is pointing up. Okay, so let's have like our test. Let's scale it to like 5. Yeah, so it's pointing up by default. Let's apply these magical rotations to it. So we're rotating Euler along the y-axis. No, we should rotate along the z-axis, 180, not 90. This is the one we should keep. If it's from the top, it should point down, otherwise we should not rotate. This we don't need anymore. This is before, because our sprites, if you remember, like when we got them from Blender at the beginning, they didn't show. So we needed to have a 90-degree rotation or export them in a different way. So we don't need this anymore. We don't need this. If it's on the top, we just need to rotate this 180, and that's about it. Yeah. That's about it. Now they look proper, except there is no separation. This is fine, easy to fix. Now I think I can get back everything, or not. Oh, I think we're being hidden by the pipes when we disappear. That's all. So potentially we just need to change the positions of things. Yeah. So the pipes are being drawn behind the background. This we can do with the position when we start. So we can give them a Z position, essentially. That's it. Set X. Yeah, I think let's have it here. So background is at 0. Let's have it at 1. The bird is at 2. Oh, background is actually at 1. No, this is a scale. It's at 0. Okay. Bird is at 2, position 2. So let's have these guys at 1. There we go. Perfect. Very nice. Don't know where the bottom ones went. So the bird is always on top because of the positioning, and the bottom ones are dead. Which can fix here. There we go. Perfect. So these guys we don't need anymore. I think except for the separation. So 14. That makes sense actually. 14. 10 gives you exactly in the middle. So we move them by 10 up, and then we stretch them. The scale is 10. So they move to the tip of the screen and they go down. Right, that's the 10. But what we wanted is a bit more below, a bit more up, to give yourself separation, I think. Yeah. The better way is, I think, pipe X spacing. Have a pipe Y spacing of like, I don't know, 5. 10 plus pipe Y spacing and Very nice. Whoa. I think this is delta time issue. I have a bug on nMage. Might be affecting things. Yeah, you saw the lag there. There we go. There we go. My bird is down. Yeah, probably delta time issues because the delta time is used everywhere. The movements essentially is controlled by delta time, and like the speeds and whatnot, if they go wrong, then we will, if the delta time is too big, then they just disappear somewhere as if a lot of time has passed. Okay, let's remove this. Let's remove these. Things are much cleaner and nicer now. We don't need this. We don't need this. Yeah, what to do with this guy? So the code is much nicer, much shorter. We only have one set of position, scale, and so on to use. I think this is beautiful. We have a simple entity class, not perfect, but as far as Go goes, might be the best way I can think of right now. And then a quad, which is essentially sprites, and a pipe. That's about it, right? Now the logic. I don't think this should regen thing makes any sense. Find pipe. So every update, I just want to see the X position, see kind of the extents. So let's take print line and takes, pipes. How many pipes do we have? Length pipes -1 and dot position rate dot straight. No, just dot X. So this is the rightmost pipe. So it starts at 6, moves back, minus, and starting at 6. Okay. -2. Yeah. Okay. Just to make sure, what's about 0th pipe? Yeah, it already starts at near 0. Okay. Now, so what we want to do, find the pipe largest X position. Can do five, and this is just I'll take first one by default. We can start at 1. Then we do position to treat, not x. So we can say if this guy is bigger than this guy. So if we have these, we can take it as the largest one. Take a pointer to it, right? So we take this. If the pipe at x is larger than largest one, yeah, that's it. So now we know where we should be. Like, what's the furthest right now? When a pipe goes all the way to the left, so I think it's like larger than -6 or so, we can just take it, move it to the position of the largest x plus some delta, right? And the delta, I think, is these two boys. We can take them. We have what, these? Oops. There we go. Yeah. Pipe x spacing. And when they are generated, you can see, so we start position 12, and then every time we make a new pipe, when we add the new pipe, we just increment by x spacing. So don't know what all of these are. We don't need. Should regen, no need. Pipe is nothing special. We can say if x position is smaller than -6, if it's bigger than, we can continue, nothing to do. Otherwise, we can say upper pipe and lower pipe, right? So what do we do? So we need to set the x positions and the y positions. Y positions are this. We randomize it. I don't think that's a good idea like this. Or are we doing it here? Wait, if it shouldn't regen, we continue. So this wasn't running. Wait, where are we randomizing the pipe y positions? The hell? Doesn't make any sense. Am I missing something? It's just rotation, quasi entities. Started this. Position. Where is the random stuff? Region was always false, so this wasn't wrong. Maybe I was wrong. Well, whatever it is, this is our Y position. This is the difference. So we have this guy and then a delta to both. So set Y per pipe so 10 plus spacing Y spacing, there we go, plus round Y minus 10 minus pi. I think we essentially always maintain a spacing. So the spacing, the distance between like the sides of the opening should never change. But now we want to take both of them and move them up or down, I guess, while maintaining the spacing. So they just should move by the same amount, essentially. And this guy should be the reverse of whatever the movement is. I feel like something's wrong, but let's see. There we go. So here we see where they're crossing the boundary. So now we need to move them all the way. So it's not actually minus 6. If they're bigger than minus 6, they're bigger than minus 9. And they're changing a lot because we're not moving them to the right. So where is this going? Yeah, it's what? Almost right. Now so we set the y's, randomize y's, and we set x. Set x. So the x is going to be the largest x position. Dot position read x plus the pipe x spacing. That's it. Same thing for this guy, just lower. New x that's it, and these guys have a new y. To make it clearer, let's make a pipe count. Maybe it starts. So instead of 5 pipes, no, yeah, just make one set of pipes, so 2 pipes. to make it clearer. So now they'll disappear. Oh yeah, because we don't have one there. That's fine. Just want to see. So the spacing is wrong. Like it changes. That's not good. Okay. So what do we want to do? This guy. Yeah, I knew this is wrong. So this will change the spacing. I think we need to anchor it to one of them. So we randomize, let's say the top one, between some set of positions. So between, I know, 5 and 15, for example. And between 5 and 15, wherever we choose it, we set it to be, we simply take that and then plus the pipe Y spacing, and that's it. So this guy, something like this is what I'm thinking. Set Y is wherever this guy is on the Y minus spacing without randomizing. We already randomized one of them. In this case, you know, it's just one. Floor 32, oh, okay, it's 5. Floor 32 is between 0 and 1, and then we multiply 5. So a maximum difference of 5 from 10, yeah. So between 5 and 15, exactly. Oof. I think we got the delta time issue again. So when the delta time, like when the cache starts running too fast, I think the delta reaches 0 and then has some very weird issues. Like the delta calculation goes wrong. And it essentially gives us a huge delta value. Okay, this is obviously not working. Does Y increase going down? No, right? Something is wrong. Let's see. Oh, this should be there. Oh, it's already 2 hours and a half. Ugh. Oh god. Minus. I think minus the Y position. Because that guy is at 10, that guy is minus 10. Positions are opposite. Something like that. Okay, is it? It's just set to negative. Oof. No. Yeah, it's pink. If it's nearer to the middle, then the guy at the bottom is like near to it. Yeah, that's not it. I think it's just too late now. Needs a rest. Okay. 10. What did we do at the start? Start's really good. So you say it's 10 plus something. And this guy is like minus 10, minus something. To give double the spacing in between. Let's do 10 minus random, but no. So if we have, let's say this guy is at position, I don't know, 10. So the other one should be the opposite. But if it's exactly in the middle, being exactly the opposite will make it meet right here. Right? What we want to do is we say, well, this guy is at whatever position. The other one is at -10 minus the separation. So like, I think it's 4 for us. And that will give us something more like this. So minus by pi spacing. But another thing is, I think this is wrong. Because this doubles the spacing. I think only one of them should have spacing. Yeah, this looks fine. This looks correct. Now we have that half the spacing. So you can just double this and get the all spacing. Yeah. Let's make it 6. Let's go to the loop and make 10 pairs again, just so we can see. All the same. Okay. So they all have this. And I think now let's say we move this up. Or I think move it down. Is this moving down? Let's move it up by 2. Nope. This should also move up by 2, which makes it -8. Yeah, there we go. So this is proper movement that kept the spacing. Okay. So for getting the x, let's say we always start at 10 and then we offset it by some value, which is this. And this is our new starting position. And this guy is starting at -10. And getting the reverse of that. So if this guy gets an offset of +2, no, it's the same. It's also rand y. Along with pipe spacing, right? Just minus. Yeah, so the offset was like +2 here. Let's imagine rand y, which will make this -8 and that one 12. That's what we want. While this one always has a minus pipe-wise spacing, which is this guy. Cool. Let's see if this works. they start off the same, which we can randomize, and they go. We should start seeing some random things, maybe. Yep, there we go. That's the first one. Cool. Now we have some kind of game. The offset is too much, but it's not offsetting up. It is actually. We have way more downs. Oof, way too much down. Is it actually offsetting up? Yeah, this one went up. Hey, that's a proper game. So I think next time we can look at scores, collision intersections, which we never did before, and we don't have a physics engine yet. This is a simple game. It's just basic boxes colliding, a small formula. But later on, hopefully, we can get into implementing physics, and God help us with that. That won't be easy, I don't think so. Especially in a good way, that actually integrates well with the engine. Now, the offsets are too much. So let's reduce this to maybe 3. And there should be offsets here as well. Let's get this code and start to randomize it. And then we can say start y stem plus rand y. We can start right here and minus start right here. Does this make sense? No, actually. This is wrong. Because, yeah, this needs a minus on the 10, not on the random. Okay. So this is fine. Oops. Random. Okay, so this guy plus rand y. This guy also plus rand y. Minus spacing. Let's have 3. Nice. Ugh, this is not nice. This is actually a to-do on nMage, so hopefully look into it. Oh god. Can we print? I'm not sure if it's exactly this, but let's do timing the dt print line. There we go. So I assume we got an outlier somewhere. So we have like 0.00 something. We have some big ones and okay. So 0.3, 0.2. We have some 9s. It's fine. +1, +9. Not sure if I'm missing something, but it looks fine. Okay. I don't know why the tendency to go down instead of up. So this is down, this is up, down, up, a bit more up, but yeah. Yeah, it doesn't seem like we get proper ups. We have a 10, sure, but plus this. I think we should also seed because we aren't seeding. So we can do this here and dot seed, and we can seed by time dot now units to make sure that the random numbers are actually kind of random. That's one thing. Might want to look at the y's. Upper y and lower y. So we have +1, which means upper one at +1 is pretty low. Right, then we have some +9s, +8s, a bunch of +8s actually. It doesn't seem like the +8 is as far as the other one. The lower looks wrong. It's not 1 point. It's 13, 17. Because it starts at 16 because of the spacing. Hmm. I think the spacing is the issue. Because it always pushes the lower pipe down, and so the upper pipe doesn't move as much. I think we should distribute it. So half the spacing goes to this. Half spacing pushes this up, and half of it pushes it down. then I think it would make more sense. I think with this, it's a really good stopping point. I like the work we did. Good updates today. It's looking like a game. Looks nice. We have some better interfaces to work with. Okay, so now we see a lot more of the lower pipe on average. We still have the same spacing. But you can see the lower, yeah, there you go. Now the upper ones are on the edge. So the spacing was biasing essentially the lower pipe down. Now we should see equal biasing in all directions. Yes, perfect. Very, very nice. Very, very nice. Yeah. And now we can actually move the round Y even more. So half the spacing goes up, half goes down. So now we can push this. So like 5. Yep, now it goes a bit more extreme. Did I not change it somewhere? Plus pipe spacing, minus pipe spacing. Let's see. Maybe bad RNG. Okay. Now obviously the disappearing is easy to fix. There we go. Cool. Yeah, this is kind of challenging. Very nice. So now we have both extremes, which we can tune. Let's fix the disappearance. If it's bigger than minus 12, maybe. You just want enough so that it goes off the screen. There we go. Now we have a proper looking game. We need some score collisions and so on. That's it. There we go. And now obviously, maybe not so obviously, but resizing shouldn't matter. Like it shouldn't affect the playability or like these numbers that we put, because these are affected by the camera, the orthographic camera. So you can see as we stretch, it maintains the dimensions. Although the bird goes away and dies. Because I think the delta time is affected. So here the delta time is going to be huge. The gravity is going to affect him a lot, yeah. And you can see even these things, they move a lot. So yeah, there we go. It got messed up because we stopped it. Okay, so I think this is a good. Do you have any print lines? Nope. Very good stopping point. We did a lot cleaner code. This got cleaned up a lot. Maybe I'll change this to sprites or give it to squads. Because sprites might mean something else. Pipe is nothing special. It's just a bit of a helper. And a quad is quad mesh with the texture. It's fine. We'll keep it for now. The bug in nMage is already written. So hopefully the disappearance thing goes away. I think that's it. Let's push. We have Let's ignore this VS Code thing. And we have entities plus squads plus proper pipe logic and more graphics. And this is day 70. Okay, I think this is it. Thank you all for coming. Hope you enjoyed. I think it's pretty nice. We'll continue doing Flappy Bird next time. We'll add collisions and scoring, and I think one day should be enough with for this. So thank you all. Have a good day.